Welcome back, Cubs. In this video, we're going to be introducing stoichiometry, and we're going to discuss mole ratios, molar masses, and the first type of stoichiometric equation, which is mole-mole for us. So stoichiometry, it's a long word, but it's nothing to get worried over. It's basically the recipe ratios for making chemical reactions. So it's going to take into account reactants and products, grams, moles, but we'll get it all sorted out by the end of this chapter. So stoichiometry is the study of quantities of materials consumed. So this would be the reactants, and the materials produced. This would be the products. Composition stoich deals with the relationship, so the ratios or the mass relationship of elements within a particular compound. Kind of related to the percent composition that we did previously, but we're going to use values, not percentages for that. And then reaction stoichiometry, important, needs to be balanced chemical equations. So make sure your chemical equations are balanced. If they are not balanced, you will not get the correct information, the correct answer there. So make sure that they are balanced because we're going to be utilizing the coefficients within stoichiometry. So four main types of stoich problems. We have mole-mole, mole-mass, mass-mole, and mass-mass. So basically the first value here, that's your given. So this will be indicated by a numerical value. And then the second word here, mole mass, that's our unknown. So our unknown quantity, this is what we're looking for. This will be indicated by the phrase how much, or determine the amount, or find the blank, and that will be your unknown. And it's a good habit to get into to write out your given and your unknown so that you know which type of the four stoichiometric calculations you need to perform. Before we get into those types of stoichiometry, we need to talk about mole ratios. So mole ratios, these are the conversion factors. This is the stoichiometric step that compares two substances in a balanced chemical reaction. So make sure that your equation is balanced. And then all we're going to do here is we're just going to compare the coefficients. So we have 4 moles of lithium to 1 mole of oxygen. So 4 moles lithium over 1 mole oxygen. Pretty straightforward. We're just looking at the coefficients. We have 4 moles of lithium and 2 moles of lithium oxide. So it's a 4-to-2 relationship, or a 2-to-1 relationship. So we can write a mole ratio. We can compare the coefficients for all of these substances, and we can have a total of 6 ratios for a 3-compound reaction. We would have 12 ratios if it was a 4-compound reaction. So see page 300 for another example. I'll do you one better. We got another example right here for you. So if we have the equation combining hydrogen gas with nitrogen to produce ammonia, what are the mole ratios? Well, we just write down the coefficients for each substance. 3 moles of hydrogen over 1 mole of nitrogen. Then we can do a ratio between hydrogen and ammonia. So 3 moles of ammonia. Whoops. My apologies on that, guys. Should be 3 moles of hydrogen over 2 moles of ammonia. We can do another ratio. We can do nitrogen and compare it to hydrogen. So the coefficient for nitrogen is 1, so 1 mole of nitrogen over 3 moles of hydrogen. We can also compare nitrogen to ammonia. We have 1 mole of nitrogen over 2 moles of ammonia. We can also compare ammonia to nitrogen with ammonia in the numerator position. We have a 2-to-1 ratio between ammonia and moles of nitrogen. And lastly, we can compare ammonia with hydrogen gas. So these are the mole ratios. We're going to use mole ratios in stoichiometric calculations anytime you have a mole over mole conversion factor, which we'll talk about here momentarily. So mole ratios, okay, molar mass. Remember, how do you find the molar mass? That's right, you add up the parts from with the values from the periodic table, and that will allow you to get the molar mass. We're going to use molar masses in this chapter as well. We'll use them for 3 of the 4 types of stoichiometric calculations, but not the mole, which we're going to discuss today. So we'll talk more about molar mass in the next video lecture. So the steps for a correctly written stoichiometric calculation. Number 1, make sure that the equation is written correctly and that it is balanced. It must be a balanced, properly written chemical equation. If not, you'll get a wrong answer. So, next step, find the unknown and the given. Determine the given, determine the unknown. Then that will help you determine the problem type to set up the equation. There's another video posted on here, stoichiometric calculation, general equations. So take a look at that general equations too. Then fill in the appropriate numbers and sig figs. Remember, we're just going to go with 3 sig figs from here on out, and then solve the problem. Make sure to cancel out the units as needed. So let's take a look at this problem here. We have carbon dioxide reacting with 2 moles of lithium hydroxide to produce 1 mole of lithium carbonate and water. So we got our balanced chemical equation. Now, numerical value, this is probably going to be our given. So our given is 20 moles of CO2. Then to find the unknown, look for the words how much, how many, determine, find the. So we're looking for how many moles of lithium hydroxide. So our unknown is moles of lithium hydroxide. Okay, so I wrote this down here, pretty much same info. We've got our balanced chemical equation. We have our given, which is in moles, and our unknown, which is in moles. So this is going to be a mole-to-mole stoichiometric calculation. Take a look at that general equation video that's posted for additional info on the setup. So we have moles, 20 moles of CO2. That's our given. Now, here, this unit, it's going to drop down to the denominator. Then, now that we're in moles, we can go to moles of another substance, moles of lithium hydroxide. So we have it set up correctly. Now we need to put in some values here. Before we said mole always gets the 1. And while that's going to be true when it's grams and moles together, we have mole over mole here. When it's mole over mole, refer to the balanced chemical equation and use the coefficients, i.e. the mole ratio. So, find lithium hydroxide, use the coefficient, it's a 2. Find carbon dioxide, find the coefficient, it's a 1, so you write a 1. Now, double check to make sure that your units cancel out. You have mole and mole. And then using your calculator, this one's pretty straightforward, but we have 40 moles of lithium hydroxide. 40.0 if you want to get those 3 sig figs in there. Then box or circle your answer. So that's how you do mole-mole stoichiometric calculations. We'll continue with the other types of calculations in the other videos. I'll also post a video for some homework help on the worksheet that is due on mole-mole stoichiometry. Have a great day, Cubs.